Now we're going to look at writing an exponential equation of an exponential function given the graph. So first identify 2 points in the graph. Choose the y-intercept as one of the 2 points whenever possible. Try to choose points that are as far apart as possible to reduce round-off error. If one of the data points is the y-intercept, then 0a, then a is the initial value. Using a, substitute the second point into the equation and solve for b. As before, if neither data point is the y-intercept 0a, then substitute both points into the equation with the form f of x equals ab to the x. Solve the resulting system of two equations and 2 unknowns to find a and b, then write the equation. So very much like we did before, but now we're going to have to look at the graph and identify points. So what I see here when I was looking at this, example 5, come on, try and change colors. Find an equation for the exponential function graph. Looks like 0, 3 is a point. It also looks like 1, 6 is a point, but it also looks like 2, 12 is a point. Well, I'm tempted to go with 1, 6. As it says, look at things spaced out. I'm going to go with the 2, 12. So I'm going to go here and here. So with the 0, 3, we automatically know that we have y equals a b to the x. We know that 3 is that point, so y equals 3b to the x. And we could plug in the 2, 12, so 12 equals 3 times b to the 2 power, and divided by 3, we have 4 equals b squared, and that's kind of nice because then b is just 2. And we have y equals 3 times 2 to the x power. It was kind of a nice one. Worked out really well. So let's go on to our next one. And she's using a graphing calculator, and I use Desmos to find the exponential equation that includes the 2 points. So I went and put the 2 points in, 2, 24.8 and 5, 198.4. I had to modify my window to fit. And then I put these points into the Desmos table. I just took screenshots from Desmos here. So then I did y1, because that's this column here, is approximately, that's that shift. You hit the shift and the button next to the 1 on your keyboard. It's approximately a times b to the x1. The x1 was this column here. And it came up with the a being 6.2 and the b being 2. So our y equals 6.2 times 2 to the x. And what's interesting down here, this r squared, for the correlation coefficient, it's a 1. The r is a 1. So this is spot on, which is really cool. Okay, granted there's only 2 data points, so it should be spot on. But the fact that our a is a 6.2 and our b, the base, is just a solid whole number there is really cool.